Uh, Good morning, all. I'm Kundan Sharma, and today we'll be starting with some fundamentals, and I'll be, I would say, covering few miscellaneous topics from the very fundamentals. That why do we need programming language, right? And then what is the purpose of a programming language? And then there are several jargons or technical words which are used in programming, which at times is difficult to understand. So I'll be covering those, and then we will be writing a small program as well using one of the programming language, which is called Java. Okay. So the first thing is why do we need programming language, right? So let us try to understand these basics, right? Give me a minute. Okay. So first of all, what is the purpose of what is a programming language, right? So why do we need programming language? We have, if let's say, if you have to talk to two human beings, if they're talking to each other, right? So they can talk in a language which both of them understand. There are various languages that we speak. We have English, French, Spanish, Hindi, or maybe there are many I would say languages which human beings talk to each other, or both of them can understand. But let's say if you have to talk to a computer, so how do you talk to a computer? So you need some sort of a language which computer can understand, right? Or first of all, why do we need programming language? Let's understand the use case. What is the purpose of a programming language? For example, let's say if I ask you to make, let's say, a pizza, right? So the shape of a pizza is what? It's a circle. If I say that you have to make a pizza, so if I say make this pizza, let's say for 30 minutes, let me see how many pizzas you can make. So you might make the best quality of the pizza because you're a chef. You'll make all the pizzas will be of the decent quality and they will have the fixed uh, diameter. But if I say that you have to make this pizza 24/7, 365 days, so what's going to happen? After a few hours, you'll see that the shape of the pizza might become something like this, or maybe something like this, or maybe the pizza will be overheated. They will not be of the consistent quality. The quality of the pizza will degrade because you are doing this task repeatedly. So the output of your pizza will not be consistent, right? So that means if a human being is doing some task repeatedly, the output of that product cannot be consistent. But if I know that what are the steps to make a pizza, and let's say if I say that okay, there are let's say 3 4 steps to make a pizza, you specify the ingredients of the pizza and you say that okay, this is the diameter and this pizza should be baked at given temperature, and you feed these instructions to a robot or to a computer. So then that robot is going to prepare the pizza 24/7, 365, and the output of that pizza will always be of same taste, same quality, and it will be always consistent. Do you understand that?
Yeah.
So basically, the output is always going to be consistent. Why it is going to be consistent? Because you have issued instructions to a computer which can perform a task repeatedly without compromising on the quality part. But whereas if I ask the same task for a human being to bake this pizza continuously, then the output of that pizza will not be consistent, right? So that means there is a requirement of a software. What is a robot? Robot is actually a computer which understands the instruction given by a human being, right? As I said, the two human beings, they can talk using the language, English, French, or whatever they understand. But then there is some language which computer understands. So what is that language that computer understands, right? So for example, if I say that, let's take a simple example. Let's say Jitendra speaks French, and this Tracy understands only English. So that means French, this person talking French and this person is understanding English. That means communication cannot happen. Both of you are talking two different languages. That means you are talking French and you are talking English. So communication cannot happen. So there has to be a common language which both of you can understand. One possible option is that there should be some sort of a translator which is required, which will take this French language as the input and convert this into English language. Then only this communication can happen. Otherwise, this guy French, if he is trying to talk something in French, the guy who understands only English, he cannot understand. That means from French to English, this communication can happen only if you have some sort of a component which does this translation from French to English. Is this clear, Tracy?
Yeah.
Now, assume that this guy who is a computer machine, right? This is a computer, and this is a human being. a human being knows only English language, right? Assume that human being can talk only English, but this computer does not understand English. So computer understands a language, a particular language, which we call language of zeros and ones. Language of zeros and ones. That means English, if the person is talking English, computer cannot understand English. Computer understands only language of zeros and ones. So there has to be some sort of a translator which does this conversion from English language to a language of zeros and ones. Is this clear or not?
Yes.
So what is that something which does this conversion from English type of language to a language of zeros and ones? So in software, we call that there is a component which we call it as a compiler. So what is the job of a compiler? Compiler will convert this English type language into language of zeros and ones. Why I'm saying zeros and ones? Zero and ones means only two possible digits, 0 and 1. Now, there is a word called binary. You would have heard this binary system. So this language of zeros and ones is called binary language. The bi means 2. Bi is English word. Bi means 2. So binary means it has only two possible digits. So computer will understand only language of zeros and ones. That means this English type language has to be converted into language of zeros and ones. So in this case, if I take the simple analogy, the steps to prepare pizza. So whatever is the steps, I'm not a chef, so I cannot tell you the steps. But for example, you have to prepare a base, you have to prepare the topping, you have to add some spices, and you have to add something on top of that, and you have to bake it. These are the 4 steps which you'll say in English. But then these instructions have to be fed to the computer. And how do you pass on these instructions to a computer? So whenever you pass, you need some sort of a language to speak. So obviously you're going to write some language. So those languages are called programming languages. Now, what is a programming language? So programming language is, I would say, set of instructions which you are writing to be fed to a computer. And programming languages are simple, something which humans can understand. So humans do not understand the language of humans. Humans understand the language of only English. If I'm writing some simple instructions like prepare the base, prepare the topping, or add some spices on this, is the English type language. So there are several programming languages, just like we have several languages such as English, French, Spanish, Hindi, or Arabic. There are so many languages out there, right? So similarly, programming languages are also there are different variations of programming languages. So this part is clear to you that every programming languages, there will be a step of compilation, which will convert this English type language into a format which computer can understand, which is called a language of zeros and ones. So this software which does this translation is called compiler. Is this clear to you?
Yeah.
So we have different types of programming languages. Let us see some examples of programming languages. So one programming language could be, I'm sure you would have heard, C++, Java, Python, Groovy, Scala, Kotlin, right? So these are all examples of programming languages. So because these are different programming languages, that means accordingly, the compiler will also be different. For example, if you are doing translation from English to, let's say, Spanish, you will need a translator which does the translation from English to Spanish. If you're doing a translation from English to French, so you will need a translator which does the translation from English to French. So for every translation, basically, you need a specific kind of translator. So similarly, depending on the kind of programming language you have, you will need this kind of software which will be a specific compiler. So we are going to talk of one specific compiler. So first of all, you understand that we have different types of programming language. Is this clear to you?
Yeah.
Tracy, is it clear? Yeah.
Yeah.
Okay. Now, so the first, we understand why do we need programming language? We need programming language so that we can talk to the computer, right? And what do we, computer does not understand the programming language. The computer understands the language of only binary language. That means you need some sort of a mechanism to convert those programming languages into a binary language. For that, we'll need something called a compiler. So the word is called compiler. If you don't remember it, don't panic. It's just, I would say, these are jargons that I'm trying to, I would say, explain it to you in simple words. Now, next thing is, how many types of programming languages are there? There are two styles of programming languages. One is called functional programming language, and another is called object-oriented programming language. So what is functional? What is object-oriented? Just like these are the two varieties, you can say. These are the two styles. You don't have to take notes, just pay attention, and you can watch the recording later on. So what is functional programming language? So as the name indicates, function, you can call it something like which sounds like a verb, right? So which sounds like a verb. And object-oriented programming language, we will understand this, what exactly is this, but first understand what is function, or what is a, let's say if I have to prepare a coffee, which I have used in my first video as well. So prepare a coffee means prepare coffee. So prepare coffee is something which I do it day in, day out. So there are 4 steps to prepare a coffee. First of all, I'll say boil water, first step. Second thing is add sugar. And then if I say add milk, and then I say add coffee, right? So these are the 4 steps which I do every day whenever I have to prepare a coffee. So if I'm issuing these instructions to computer, so what do I need to do? I need to issue this instruction one by one. First of all, boil water, add sugar, add milk, add coffee. If I issue these 4 instructions to the computer, how many lines of instructions I need to write? I need to write 4 lines of instructions. So for 1 cup of coffee, I need to write 4 lines of instructions. If I need 10 such coffee, how many lines of instructions I need to issue the computer? 4 times 10, because for 1 cup of coffee, I need to issue 4 instructions. For 10 such coffee, I need to multiply for 1 coffee 4 steps, for 10 feet, so that means 40 instructions I need to write. That means, is there any better way to do it? So the answer is, instead of repeating these instructions, what I will do is I will say that I'll wrap these 4 instructions into a structure, and I will call it something as a procedure. Let me name it as a procedure, or I will call it as a function. So what is procedure or function? It is some sort of a structure in which I will write all the steps which can be repeated again and again whenever I need it. So where do I need some any set of instructions which you need to repeat every day, right? Or maybe multiple times. So rather than writing all those instructions multiple times, you'll wrap this inside a structure and you'll call the structure as a procedure or a function. Is this clear?
Yeah.
So for example, now if you want 10 coffee, how many times, if you call this procedure once, let's say if you say prepare coffee, if you call this instructions once, it'll means for 1 cup of coffee, you have to call this procedure once. If you want 10 times of coffee, you have to call this procedure 10 times. That means you have written this instruction only once. So whenever you call prepare coffee, computer will go and read, okay, to prepare a coffee, I need to execute these 4 steps. So computer will execute this. Again, when you call prepare coffee, again, computer will go and see, okay, I need to go and execute these 4 steps. So it's a better way. It's a better way of, rather than repeating the instructions, writing these 4 steps again and again, you have written it once and you have given it some name. In simple words, in real life, where do we use procedure? For example, if you're working in a company, every time a new employee joins in an organization, so we call it as an induction of an employee. So what happens in the induction of employee? There are 4 steps. I would say there are some standard steps. For example, every employee will get an ID. Issue an ID to an employee. Issue an ID card to an employee. This is the first step. Whenever you join an organization, you'll get an issue, and then you'll be allocated a seat where you'll be sitting, right? Allocation of seat. Second step. Third is employee has to be allocated a bank account where his salary will be credited. So bank account creation, because you have to be paid salary. The fourth is you have to allocate some task or allocate some project. So do you do this one time? Answer is no. Every time a new employee comes, you have to perform these 4 steps, isn't it? So this is a repeated set of tasks which you do it day in, day out. So if something which is repeated, rather than writing all those steps again and again, you'll say that let me wrap this procedure and I'll call it as a induction of employee. So whenever any new employee joins, I'll say go and call this procedure and execute whatever steps are written. So this is called basically procedure or function. We all understand this part. Is it clear?
Yeah. Yes.
So no surprise, no nothing, no technical word. I'm just trying to explain in a layman's term what exactly procedure means. So procedure means a repeated set of instructions. You wrap it inside a structure and you call it as a function, right? So now we have two types of programming languages. One is called functional style. Let me write down programming languages. So this is called functional programming language. Functional programming language. And the second one is called object-oriented programming language. So functional programming language, where everything will sound like a procedure or a function. Just now I explained that what exactly is a procedure or what exactly is a function. Is this clear to you, Tracy, Jitendra?
Yes.
The examples of functional programming languages are, I would say, C. C is an example of functional programming language. I would say it's a very old type of programming language. Now, the industry has moved from functional object programming language to object-oriented programming language. I have explained in the previous video that there are some problems with the functional style of programming languages. For example, as I said that if you say prepare coffee, if I just say prepare coffee, the same example, I know that there are 4 steps: add water, add sugar, add coffee, add milk. But for example, I want to make some more functionality to it. I would say I would like to make, let's say, cappuccino coffee. So that means I need to write some more instructions. Or if I say tomorrow I would like to make it, let's say, latte coffee. So again, I need to add more instructions. Or I would like to make, it's a spice tea, let's say cardamom tea, or maybe some special flavor tea. I need to keep, that means I am adding more instructions to the same function, which is called prepare coffee. So over a period of time, what is going to happen? Your code base the number of instructions will be quite large and it will be difficult to maintain that code. It might happen that you're trying to add an instruction to, let's say, to make a latte coffee, but it is going to, it might introduce some problem in the functionality of a normal coffee, and you might introduce some defect, right? So your coffee vending machine will stop working and it will start producing some weird outcome. The coffee functionality not work properly. That means there was some lot of problems in the functional style of programming languages. So in order to avoid those shortcomings, other variety of programming languages came, which is called object-oriented programming languages. So there was some problems in programming languages. I don't want to go into those details, but I just want to focus on the object-oriented programming languages. But this was a very high-level overview. Is this clear to you, to both of you?
Yes. Yes.
So now, then the era came of object-oriented programming language, and so some problems which was there in the functional style programming language was, number one, I would say the code. I'm using the word code. What is code? Code means it's not something like some secret code, or I would say it's talking about the instructions, the programming language, whatever we say, whatever instructions I'm calling that as a code. Whatever instructions we write inside this procedure, we call it as a code, right? So this code was not maintainable. When I say code was not maintainable, I'm talking about the instructions, whatever we write inside the procedure, right? So the code is not any, I would say, technical word. Just assume in simple words, whatever instructions I write, that became, once it becomes, once it grows in size, then it becomes difficult to manage, because you're trying to stuff all the logic, all the functionalities inside the same procedure. In that case, what's going to happen? Probably you might end up mixing some of the things, and your program may not work properly, right? So code was not maintainable. It led to so many defects, right? So it was a defect prone. Now, what is defect? Again, defect is not something like just consider as an English word. Defect means what? Something which is not working fine. That's called defect, right? That means the code was not working as per the expected output. So this code was defect prone. It was not maintainable. Maintainable means was you are trying to change some functionality, and you should be able to maintain the quality, and it should keep working as it is expected. But it was very difficult to maintain. So if you want to add some new functionality, it might take a lot of efforts to introduce some new feature. There were a lot of shortcomings. All those problems were fixed with other type of programming language, which is called object-oriented programming language. Is this clear to you?
Yes.
Now, what is the example of object-oriented programming language? Why I'm saying object? So the word object is something which you see in real life, which you can see it, which you can feel it, right? If I say car, so car is something, a physical entity which you can actually see it. If I say employee, employee is somebody who you can physically see it. So class or object, so sorry, I'm using the word object, which is anything which you can actually see and observe. Say something which you can physically see and observe. I mean, it's I would say you can very easy to visualize and you can fix the problem. Yeah, just give me a minute. Yeah. So if I say what exactly is an object and why it solved the problems, so it was very easy for me to locate the source of the problem, right? If there is some problem in my software, I can easily figure out and I can easily sort those, fix those problems. So let's take an example of what exactly is an object. What do I mean by object, right? So I'll simply take you to a different level of discussion here at this point. I'll be using the word something called object. Now, what is object? Object, it has something which has some characteristics, right? It has some characteristics, or I an English word, right? Please don't think I'm using any technical word. Characteristics or features. I mean, it's an English word, right? So every object will have some characteristics, some attributes, some features, right? If I say, let's say if I'm talking of example, let's say employee. Let's take an example of Jitendra. So who is Jitendra? Jitendra has some characteristics. For example, Jitendra has, so what is characteristic? He has gender, he has height, he has weight, he has profession, right? So Jitendra is somebody which I can physically see it. And Jitendra has certain attributes: gender, height, weight, and let's say profession. What is gender? Gender is male. Height is, let's say, 5 feet 6 inches. Weight is, let's say, 75 kg. And profession is, let's say, he is working as a chef. So these are the characteristics which describe this something which I'm calling it as an object. So you can see here, Jitendra is what? Jitendra has these characteristics: gender, height, weight, and profession. And the value of these attributes are male, height is 5 feet 6 inches, weight is 75 kg, and I would say the profession is chef. If I say Tracy, so Tracy, again, she will also have some characteristics. This is gender, and this is height, and this is weight, and this is profession. Gender is, let's say, this is female, height is, let's say, 5 feet, and let's say 4 inches, weight is, let's say, 65 kg, and profession is, let's say, she is a businesswoman. Sorry, I'm just not writing the whole stuff. Just maybe you can correlate it. So again, Jitendra is something which I can physically see it. I can see here that Jitendra has these attributes. Tracy also has these attributes. But what is common among these two things? The common thing is I can generalize these two. I can generalize these two and I can call them as person. So what is this person? Person is something you can call it as a template. Or maybe you can call it as something like a common noun. An English word, common noun. If I say, can you give me an example of a person? So Jitendra is an example of a person. Is a specific example of a person. Can you give another example of a person? The answer is Tracy is another example of person. So example. Or if I say instance, again, instance is not a technical word. We use it in our English communication. For instance, for example, these are all English words, right? Or I would be using the word terminology called object. So example, instance, object, I'll be using is very frequently in my training, right? So what exactly is this person? Person is something like which is like a common noun, or which we can call it as a template, or which has the specification. Specification. What is specification? It will tell that what all attributes person can have. So person will have the attributes you can see here. It will have, person will have gender, person will have name, height, weight, and profession. This is how you will define a person. Now, if I say, can you create a person based on this template? So answer is Jitendra is a person which is based on this template. Jitendra has all these characteristics. Similarly, if I say, can you create another person based on this template? So Tracy is another person which is based on this template. So Tracy also has these characteristics: gender, height, weight, profession. So you can see here, we can call this person as a template or as a specific template which has the specification that what all attributes its object are going to have. So person says that, okay, I have decided a layout or a design that person is always going to have these characteristics or features or these attributes. Every object that I try to create out of this person will is going to have these attributes, and the value of those attributes could be different. Is this point clear to you?
Yeah.
Yes.
100% clear?
Yeah.
So class is, I would say, something like a blueprint which has the specification, and every object that comes out of it, I would say that is called, sorry, a class is a template, and everything which is an example of that class, we call it as an object. In simple words, let's say if you have to figure out, if I say X is an example of Y, if I write something like this, X is an example of Y. So one of them is a class, one of them is an object. So always I say Y is a class and X will call it as an object. Right? So Y is a class, X is, so what we can write here, if I say here apple. So apple is an example of fruit, isn't it? So what is fruit? Fruit is a class, apple is an object. Is this clear?
Yeah.
If I say, let's say orange. So orange is an example of fruit. That means if I say what is a fruit, how will you describe a fruit? So fruit will have certain characteristics. For example, fruit will have, let's say, what do you call, seed. Some fruits have seed, some fruits don't have seed. Fruit will have a taste, and fruit will have a color. Right? If I say some fruits, let's say if I'm talking of apple, right? So apple will also have seed, taste, and color. Some apples are, I would say, sweet in taste, some are sour in taste, right? Or seeds, some of apple will have, I would say, they will have seed. But if I say orange, right? So I mean, orange do not have any seeds, isn't it? Or do orange? Sorry, I forgot. Orange has seeds. Okay, maybe you can. Sorry. All I'm trying to say is that orange will have a separate. Orange will not be sweet. Orange will always be sour in taste. Apple will always be sweet in taste, right? So some the color of orange will be always orange, but apple will be always red in color. So if I say, give me an example of a fruit, so apple will be an example of a fruit. Orange will also be an example of a fruit. Guava will also be an example of a fruit. All these are called objects, and they will have these characteristics: seed, taste, and color. But the value of those attributes will be different. Is this point clear to you?
Yes.
100% clear?
Yeah.
So what are we trying to do? As I said, that I just tried to explain this class and object. Class is something like a template, or you can call it as a common noun. Object is called as a proper noun. So if we take many more examples of class and object, you can understand. If I say vehicle, so can you give me an example of vehicle? So the answer is car is an example of vehicle. Can you give one more example? I'll say aeroplane. Aeroplane is an example of vehicle. Another example, bike. Bike is an example of a vehicle. So car is an example of vehicle. Aeroplane is an example of vehicle. Bike is an example of vehicle. So I will call vehicle is a class, and I'll call them as object. Is this point clear to you?
Yeah.
Now let us try to understand. So I said that we are now talking of, we start with programming languages, functional programming languages, and object-oriented programming language. Object-oriented programming language. In this case, I use the word object versus class. So class is always generic, object is always specific. Class is something like a template, and object is something which is based on that template. Is this clear to you?
Yes.
Now, right, I will just try to explain. So if I say student, so student will have certain characteristics, certain attributes. How will you describe a student? Student will have a name. Student will have a roll number. Student will have a subject, right? So in I would say any object, right? So student will have, these are called name, roll number, and subject. These are called attributes or characteristics. And student will also exhibit some behavior. Student will perform some action. So how does what the student will do? we know what is so the way student behaves, expresses the behavior by making use of methods. So there are some actions or sorry, let me rephrase. So student will have the attributes and student will always express the behavior by doing some action. We said that what is action? Whenever we say action, that means we are always talking of methods or function, right? So if I say student is a class, so class will have three things. As a class will have always two things. I have drawn a rectangle here. So this is the convention or the way we represent the structure of a class in any programming language, right? So this style is called, if at all I need to represent the structure of a class, so we use a specific language. I mean, the software developer people, they communicate with each other using a appropriate language to tell the structure of a program. That language is called unified modeling language. What is unified modeling language? It's something like where you're trying to convey the structure of a program. For example, if you are a builder, if you're trying to build a house, you have to tell the customer that how does the house will look like. So you will say that, okay, your house structure will look like that. This is the layout. This will be the living room, and this will be the dining room, and this is the kitchen area. This is the reception area. So do you build a house and then show to the customer? The answer is no. You have to have some sort of a prototype or maybe some sort of a map drawn on a piece of paper, which you can show it to the customer, and customer can visualize it. Okay, this is how my house is going to look like. We'll not design the whole house and then we'll say that, okay, this is how the house looks like. Is it making sense what I'm trying to say?
Yeah.
So builder will always tell the customer that the layout of the house. He will not first of all build the house and then show it. So similarly, as a programmer, if I'm trying to write the structure, there is a convention, there is a language which programming the software people use to communicate with each other, that how the program, how the class is going to look like. So that language is called unified modeling language. It is only used for communicating between, I would say, the two people who understand programming language. So this is called a unified modeling language. So we'll draw a rectangle. It will have three sections. In the first section, we're going to write the name of the class. So name of the class will be student. And in the second slab, we're going to write the characteristics or attributes or features. So let us say, for simplicity, I'm going to say name and roll number. We all understand this part, name and roll number. And then we'll say student will exhibit some behavior. So what student will do? Student normally he study. Study is a kind of behavior, right? So it's if I say study means whenever a student will study, we can call it as a method. I'm using this is called parenthesis, right? So the way I write here is, the way I write the name of the method is I use this kind of bracket. This is called parenthesis. Parenthesis, right? So I have used this word. So this denotes that if I have to distinguish between whether it is a method or an attribute, so if anything which has this parenthesis, it means that it is a method. It is not a attribute. You can see this attribute does not have any bracket. Is this clear?
Yeah. Yes.
So
Yes.
this is characteristic and this is method. Study, the student also sleep. So you can see here study, sleep, they all sound like a verb. And if I say name, roll number, they all sound like a something like a noun, right? They are not sounding like anything action. Anything which is action, which sounds like a verb, we call them as a method. Why do we have method? Method is used to exhibit the behavior. So what does the study will exhibit? It'll exhibit the behavior of a student. So student, what does it mean? Study is a method which exhibits the behavior of student. Sleep. So sleep is also a behavior, right, which is relevant to student. Is this point clear to you?
Yes.
So every class, this is what class. Again, I said that what is a class? Class is a template which will have some attributes, if you say name, roll number, and subject, if you try to generalize it, what are you trying to do? You're trying to name, roll number, and the attribute is actually sort of a data. It stores the data. Whose data it stores? It stores the data of the student. And if I say study and sleep, what does it do? They exhibit the behavior. So that means in any class in general, we'll have two things. Some attributes which stores the data, and something to exhibit the behavior, right? So attributes plus behavior. How do you exhibit the behavior? By making use of method. Is this clear to you?
Yes.
So attributes plus some behavior will be there. So if I say
Yeah.
employee, so what is employee? Employee is a class. Employee, how, if I say, can you please describe an employee? So you'll say employee will have some characteristics. What will characteristics? Employee will have employee ID. Employee will have a name. Employee will have a department. If I say, how does employee exhibit the behavior? So I will say employee will work. Employee will gossip. Yep. Employee will play during the lunch time, whatever it is. So it need not be relevant, but let's say work, gossip, play. This is how all these they sound like a verb or an action.
Mm-hmm.
Is this clear? And what is this employee ID, name, and department? These are basically characteristics or features, you can say, where we have the data related to employee. Is this clear?
Yeah.
So this is, I would say, a very conceptual level stage. I have not written even a single line of code. I have just explained what is the purpose of a programming language. Programming language is just basically, the whole purpose of programming language is to communicate with the computer. We always speak in a language which is something which is something like English type language, right? So those English type languages, computer does not understand that English type language. Computer always understands the language of zeros and ones. So whatever human being we speak, we always talk an English type language. So we categorize those languages as, we call them, those languages as a high level language.
Mm-hmm.
We call it as a high level language. So, and computer understands low level language.
Okay.
What is low level language? Language of zeros and ones. We also call it as a binary language. What is example of high level language? Example of high level language is the different programming languages such as Java, C++, Python, Scala,
Mm-hmm.
Groovy, Kotlin, or JavaScript. These are all different programming languages. They are called high level languages because they are just like English. We all human being can understand this. Is this
Yeah.
clear?
Yes.
So whenever we issue instructions to the computer, these high level languages have to be converted into low level languages. Clear?
Yeah.
Okay. So this was first thing. Next thing is, so this was just, I would say, a high level overview. Why do we need programming languages? Okay. So in the next class, we are going to cover basically what are different jargons are there.